YouTube, this is Umozo3. In the previous lesson, we talked more about callable instances, right? We're building up this idea that we can basically have an instance of a class be treated as though it were a function that we could pass inputs to. So basically what we're going to do is look at another example of that in this video, right? We basically had two examples, and so we're just going to pick up and talk about stacks in this video. So if you wanted to see an easier example, a simpler example with queues, you can go back to the previous video, but let's pick up from where we left off. So essentially there's a class called myStack, and so we create a constructor, and we're allowed to have a collection of arguments coming into the constructor, which will be treated as a tuple. And so maybe the tuple will be empty, in which case this variable k defined on line 29 would be assigned to -1, and then this loop on line 31 would not run. But if you are passing arguments in, you're going to say consider equals start from bottom of k, where k would be basically the last valid index position in the tuple. It would be like the last element that you passed into the constructor. And then you could say if that element is not in self.items, self.items.append of consider. So initially, when we first create the stack, we're only going to permit unique elements, right? And then we could say is empty, return length of self.items equals 0. Very straightforward instance method to determine whether or not a stack is empty. And then you could push an element onto the top of the stack, so self.items.insert of 0, item, return item. You could remove an element from the top of the stack, so to remove equals self.items of 0, self.items.remove of to remove, return to remove. And then you could look at the top of the stack without removing it, so return self.items of 0. You could print the stack, so you could say for each of the elements in self.items, print of element. Then you could also have a string representation of a stack. So here the particular string that's returned by calling this method is the empty string, but when you call the method, it's going to make a call to the print stack function. So it is going to print each of the elements in the stack. But if you set the result of this str function, like if you set a string or a variable equal to an instance, and then you try printing it, then that particular string would be the empty string. So hopefully that's clear to you. And then you could have the length of an instance. The length of a stack would just be the length of the list that implements the stack. And you do that with a magic method. And you could add an element, add a stack onto another stack, right? So basically this allows you to pass in some other instance of the stack class. And you could say, while that other stack is not empty, self, so onto my stack, I'm going to push the pop, like the top of the other stack. And so we're just going to keep removing the top element from the other stack and bringing it on to be the top of our stack, right? Over and over and over again. And then we're just going to return our stack after having done that. So A plus B will return A with all the elements of B added on to A. So it returns another instance of the stack class after we pushed elements onto our stack. And then we can also have a get item dunder. So like we've said multiple times throughout these 59 or 60 videos, it defines X of item, right? And so basically you would have like square brackets, but you could pass a keyword, you could pass a key into an instance of a class as though it were like a dictionary that you were trying to get a value out of. And so if the item is equal to top, you could return the top of the stack, self.peak. If item's equal to bottom, you could return the bottom of the stack, self.items of length of self.items -1. If you say that you want the length or the size, we could return the length of the stack, which we said in another magic method is the length of the list that implements the stack. Okay, if you say random key, X of random key, just print or just return random value just to show the workings of a dictionary. Key value, input, output, right? If item is equal to items, what if you say, X equals my stack, and then you say print X of items, where items is in square brackets? Well, that would just return that stack. So it would make a call to the str method, right? It would be a string representation of the stack instance, right? Otherwise, if you don't say X of top, X of bottom, X of length, X of size, X of random key, or X of items, you could print not a valid key and return none. So this is like the absence of a data type. And also the set item dunder. So this defines X of item equals value. So what if you wanted to modify the instance in some way? So if you say if key equals new top, self-top push of value, right? So it's just declaring a new top being added onto your stack. And then you could say replacing top, and then so that would have to pop the current top of the stack, and so that you could add a new top onto the stack, so it would replace the top, right? And then you could also otherwise say not a valid key, enter new top or replacing top with the escape sequences for the double quotes. And then for this call, we're going to pass in a collection of arguments as though they were coming in as a tuple. And you don't have to do that. So you could specify that you're just going to accept 2 arguments or 9 arguments, right? You could have default arguments if you want. You could have said W equals 3, and then presumably that would accept 1 argument called W, but then if the user doesn't pass in anything, it's okay, because then W would take the default value of 3. But then this defines X of tuple args, right? It's kind of like the get item dunder. But here, instead of thinking about the instance as though we're a dictionary and having square brackets, we're going to think about the instance as though we're a function and have parentheses. So if they don't pass in any arguments when they make a call to this instance, then if the stack is empty, we'll just say no elements and return false. Otherwise, if the stack's not empty, we'll just return the top of the stack. But otherwise, if they do pass in arguments when they call the particular stack, we're going to iterate through. So we're going to say q equals 0. While q is less than length of tuple args, response equals input of, want me to add this onto the top of the stack? Yes or no, y or n, and then string of tuple args. So it would show you the element that's being considered to add onto the top of the stack. And then if they say anything other than y or n, we're just going to ask them over and over and over again, right? We're going to say pass, and then nothing happens to q. So like this Boolean is really not going to change until they type in either capital Y, lowercase y, capital N, or lowercase n. And then that would have the effect of either pushing that next element onto the top of the stack or letting the user know that the element is not going to be added to the top of the stack. So hopefully that's clear to you, and that's how the call works, right? And we can go ahead and see another example of that. So I'm just going to run main.py. I guess I need to go ahead and call the function here. So let's just call it right here. So I'm just going to say try stack. Okay, and so I think we already saw this in the previous video, but I want to do a brief little review. So it's going to say awesome equals new stack. So why does it say that? Because remember, in the constructor on line 27, we said that every time we create a new stack, we're going to print this line, awesome new stack. So hopefully that's clear to you. And then it's going to say length of stack would be 3, because we said that we're only going to add elements onto the top of the stack at the beginning when the stack is first created if those elements are unique. And then is it empty? Well, no, clearly it's not. So string of a dot is empty, right? A dot is empty is a Boolean, and you cannot concatenate a string directly with a Boolean. You'd have to convert the Boolean to a string. And then you could add 15, so that would push 15 onto the top of the stack. And then you could add 20, but then you're just going to remove 20, right? So you would say string of a dot pop, and then 20 falls off almost as quickly as it came on. And then you could treat the instance as though it were a dictionary. So you could say a of new top equals sup. And so that would have the effect of pushing sup onto the top of the stack according to the set item dunder that we talked about a few minutes ago. And then if you say a of replacing top equals, and then we have a format here, we have a string format. So b concatenated with not much. Well, what is b? b equals a of top. Well, according to the get item dunder, a of top would be sup, because that like peaks at the top of the stack, right? So it'd be like sup not much is going to be your new top of the stack, right? And then what we could do is we could also make a call to the instance of the class, right? So A is an instance of the stack class, but it looks like a function here. And that's what the call magic method allows us to do. So we're going to say A of 400, 800, 800, 800, 900, and try to ask the user if they want to add each of those elements onto the top of the stack, right? And then presumably if they say yes on 900, then that would be the top of the stack. But anyway, we're going to be asked if we want to add 400, so we're going to say no. And then for 800, we're going to say potato. So that's not a valid input. And then the value of q in that while loop, remember, is not going to be updated, right? And so we're just going to have to provide a valid input. So I'm going to add none of the 800s, but I will add the 400 and the 900, right? And then I guess if we go ahead and run it, it says, okay, adding 900, right? And it says 900 and then sup not much, and then 15 when we pushed 15, and then 2, 1, 8, because those were the unique elements that were added onto the stack when we called the constructor at the beginning. So that's how what a callable instance is. As long as you define a call magic method in your class and you create an instance of the class, then you can treat the instance of the class as though it were a function that you could call, right? And then you could also decide to return things. So what if you say q equals a of 400, right? So now we would be calling the magic method and seeing the output of it. So now we could go ahead and run it again. So I'm just going to say no. no, no, yes, no, right? And so then it would just say true here at the end, because we said that we wanted a true Boolean if elements ended up getting added on to the top of the stack. That's on line 176. In this video, I wanted to briefly talk about one more magic method. It's very simple, it's pretty straightforward, but it's called the contains magic method. And basically that allows you to define what it means to ask if an element is in an instance of a class, right? So we've already seen how we can treat an instance of a class as though it were like an operation, like a number, like a plus b, or to see if it's less than something, right? That's important if you want to try to sort a list or something like that. And then we can also treat it as a dictionary, or we can treat an instance of a class as though we're a function, as we just talked about. But with the contains, we can say return W in, and then basically some instance of your class. So anyway, the contains magic method defines what it means to say A and X for some element A and some instance X of a class C, in which this magic method is defined. For some element E in stack S, we'll say that E in S returns true if E in S dot item. So if the element is in the list that implements the stack, like obviously that would be a pretty intuitive understanding of what it means for an element to be in a stack. Is it in the list that implements the stack? So we would just return true if W, this element that we're asking for, is in self.item. So presumably you need to pass in an argument when you use this contains magic method, because like what element are you trying to see is in the instance of the class? So this allows us to say W in X for some instance X of our class. So anyway, we're just going to see a quick example of that. So I'm just going to make this simpler here. So we're just going to say A equals my stack of 8, 1, 1, and then we could say print of 8 in A. And so that gives you an example of how the contains magic method works. And it's just going to say true here, right? But then what if we say print of 15 in A? Well, according to how we defined our contains magic method, this in instance will only return true if that element is in the list that implements, that represents the stack. So hopefully that's clear to you, but that's a very, I think a pretty straightforward understanding or explanation of how the contains magic method works. It just allows you to define what it means to say that an element is in an instance of a class, right? And with a stack, it's pretty obvious. Just check to see if it's in the list that implements the stack. So hopefully that's clear to you. There's a couple more things that we can talk about in this video, some pretty simple things, right? So we're going to think about keywords, okay? So we're going to think about keywords in Python. So if you've been writing in the PyCharm IDE, you've realized that sometimes there will be particular words that show up in orange, okay? And so we've seen examples of that, but what we're going to do is we're going to think about briefly a module, okay? And so you're going to want to study the keyword module, okay? And this is a module that you want to import. So at the top of your executable Python file, you're going to write from keyword, import is keyword. And in previous videos, we talked about how that's the way that you would import a particular function or a particular constant from a Python package, from a Python library. So we could go ahead and do keyword Python and briefly study the documentation here, right? So you'd be wanting to look at the documentation, right? And there's a function called iskeyword of S, right? And so basically it accepts one argument and it returns true if S is a Python keyword. So what are keywords? True, false, none, and, as, assert, break, continue, def, for, finally, in, import, pass, while, with, yield, okay? These are some important words in Python that have very specific meanings. And so it's not valid to like set a variable. You can't call a variable finally, because finally has a very particular meaning in Java. And so those are called keywords. And so you're going to say from keyword, import is keyword. You're going to import a particular function from the keyword module. And I just want to try running this for you so that you can get a sense of what's going on here, right? So we're just going to say try keyword, and I just want to show you what would be going on here, but we're going to remove the call to try stack because we're done talking about that. Try keyword is not defined, so I guess I'm trying to call the function. Oh no, it's case sensitive, right? So function calls in Python are case sensitive. So now if I go ahead and run it, So we're going to see a couple things printed on the console, right? So any word that shows up in orange in Python is called a keyword, and it has a very specific meaning, like def, or yield, or for, or break, or true, or in. Okay, so is sup a keyword? Print is keyword of sup, so that's not a keyword. What about int? No, int is not a keyword. It's a data type, but it doesn't show up in orange, right? So it's not a keyword. What about is keyword of int of 0, 2? Well, that would be basically what would be returned here. So this would be in, right? So that would be the string in, and that would be a keyword. So that's why you get true. What about is keyword of print? That would be false. Print is not a keyword. What about is keyword of false? No, because this would be case sensitive, and false is with a capital F. What about is keyword of tr concatenated with ue? Well, that would be a keyword. What about is keyword of con concatenated with capital TIN-U but lowercase? Well, that would be indeed a keyword, right? What about def? That's a keyword, but dict and self are not keywords because they don't show up in orange, okay? Is yield a keyword? We could say print is keyword of yield, so yield is a keyword. Remember, we talked about yield when we were talking about generators, about basically these items that yield or return elements one at a time, and that makes them a little more efficient with memory usage. But the point is that yield is going to be a keyword. Okay, what about range? Range is not a keyword. Range is an important and a special and a commonly used function in Python, but we would not call it a keyword because it doesn't show up in orange, right? You could say yield right here, but then if you try saying range, that does not show up in orange, right? It shows up in purple because it's like a function, right? And then if you say print is keyword of break, that would be false because again, we said that this is case sensitive, right? But if you write break with lowercase, then it would show up in orange. So hopefully that's clear to you. For the last 3 minutes, I want to basically tell you that you can check the type of a particular element or item. So what we're going to do is we're going to think about a function called try type, and we're going to say a equals int of 400. Okay, so this will be the number 400. Float of 400, that would be 400.0. String of 400, well, that would just be the same thing. That would be the, the characters 400. Bool of 400, well, this would be true. List of 400, 400, right? I guess those would all be strings. We'd have like 4, 0, and 0, right? And then you can keep going down the list, and hopefully you could fill out the last few here. But we're going to say I equals my q. I guess we deleted the instance. I deleted that class. So we're just going to say j equals my stack. So it's going to be an instance of the stack class that we talked about earlier in this video. And so I'm just going to go ahead and make a call here. So I'm just going to say try type. And so there's different things that we're doing here, and I have just enough time to explain what's going on here. I'm just going to delete that. Okay. Okay, so basically what we can do is we can check a data type of a particular element or item or variable in Python. So we're going to say for k in range of 0, 3, we're going to say print of type of my tuple of k. So type is a function, so you call type of x, and it returns the type that x is, right? And so this would tell us that a is an int, that b is a float, that c is a string, that d is a boolean, that e is a list, that f is a tuple, that g is a set, that h is a frozen set, and then that j is an instance of the myStack class. That's why it says class main.myStack, because the myStack class is defined within the executable Python file called main, right? But for the first three, that's what we would do with the first three. So for the int, float, and string, that's what range of 0, 3 would tell us. What about for v in map of type, my tuple from 3 to 5. So this is an example of tuple slicing and the map of function iterable generator, right? So type is a function, and it would just tell you the type at index position 3 and the type at index position 4. So that would tell us bool and list. That would give us the next two. And then we could say q equals type of my tuple of w for w in range of length of my tuple if w is greater than or equal to 5. So this is called a list comprehension, and it's something we talked about in a previous video. But we could say for u in q, print of u, and that would just tell us the remaining types within this tuple, right? And so that's where we would get, I guess, tuple, set, frozen set, and myStack. But the point is that you can use the type function, and you can say type of x, and it'll tell you what class, what data type that particular element belongs to. And then also remember that there's a keyword package, which provides a function called isKeyword, and you pass in a string, and it'll return true if it's a Python keyword, if it would show up in orange. So hopefully that's clear to you and that's interesting to you. I think this is very much the last video in the Python programming. From Emails03, thanks for watching, and please subscribe.